It's sunny outside. You want to go out for a walk, but the forecast says there's a 50% chance of rain later this afternoon. Instead of risking it, you decide to stay inside. The afternoon passes and there is still no rain. Now you're pissed.
What the fuck?
So what does it mean to have a 50% chance of rain? If we take directly from the National Weather Service, the definition provided is kind of confusing, so let me help visualize. There's many factors that come into play here, but I'm going to show two examples of two different types of storms on New York here. So let's say our forecast area is this county right here. So the first type of storm you have is kind of a line of storms like this, where you have just a bunch of storms that are just lined up and they could stretch for hundreds and hundreds of miles. Now, obviously, these lines don't last forever and they kind of pulse in and out as they go along. Let's say that this line is approaching our county here. So it's kind of going this way. However, it starts to shift this way. And so now we're only 80% sure that this line is going to hit any part of our county. So we're going to put 80% chance of even reaching our county. Furthermore, the sun has set and the area has cooled down. So that kind of reduces the energy that the storm has to remain strong. And so you kind of get these breaks in here. Let's say that area, there's no rain. All of a sudden, this area doesn't have rain. This area doesn't have rain. And so now let's predict that 80% of our county is going to get rain and 20% is going to miss out. We have these two probabilities. Now let's just multiply this. So 80% is the same as 0.8. We can say that 0.8 times 0.8 equals 0.64, which is the same as 64%. So if you live in a city somewhere in this county, let's say right here, you have a 64% chance of getting rain. Anyway, I have a blank map here because I'm going to show you the much more difficult type of precipitation to predict, which is pop-up storms. Now, if you live in the South or in many Asian type countries, then you probably run into pop-up storms where it's just a clear day, but then all of a sudden a cloud forms and it starts pouring. Now, these things are extremely hard to predict when there isn't much of a structure that forecasters can go off of. You know, within our line here, at least you kind of have some ongoing rain and it's moving in a certain direction, so you can kind of tell. In this kind of just happens due to an unstable atmosphere. So let's take a guess and say that storms probably won't form, but if they do, then we might see only one or two. And so we can give a 40% chance that there's rain somewhere in this county. Let's say that storm forms, and I'm going to mark it here. If that storm does form, it's going to move through this area and cover this amount right here before leaving the county. And let's say only 20% of the area will actually see the rain if it does form. If we widen out and say all of New York, if there's one storm that's this big, it can only, travel this way, and it's only going to be able to cover this much of the area. So all of this isn't going to get covered. So let's just say 20% of the area will get covered. We can multiply 0.4 times 0.2, and that gives us 0.08, which is 8%. So we have an 8% chance somewhere of any place in this area to get rain. Difficult thing about weather prediction is just its unpredictability. There's this whole idea of chaos theory and the butterfly effect, where a flap of a butterfly's wings somewhere across the world could trigger a tornado in Texas. And so I want to go over chaos theory and how it applies to weather in a future video. Subscribe.